Okay, so ସମସ୍ତଙ୍କର internal exams are continuing. All of you are having your internal exams, and in view of those exams I thought that we should have a short recap of whatever we have covered in the class. Many of you have attended the class, I know, but nevertheless, for those who haven't been able to come across or were absent due to any reason in the class, I hope it's helpful. Okay, so for kinematics, right, the parts that will be covered in the internal exam will be dealing with distance, displacement, velocity, acceleration. Now mostly these are all very easy concepts, right? So normally let us consider a two-dimensional plane, right? And if you move from one point to another, or from an initial point to a final point, it is said to be motion. Now specifically, what is motion? Motion is the movement of a body with respect to a fixed reference point, which in this case is the origin 0 0, and also with respect to time. So when you considering motion, you are considering two things. You are considering position with respect to reference and with respect to time, or the change in position. So that brings us to distance and displacement. So if you're going from an initial point to a final point, say you can take path number 1, you can also take path number 2, and you can also take path number 3. Note that path 1 and path 2, they are longer than path 3. In fact, path 3 is the shortest measuring path from the initial to final point, and 1 and 2, they reach from the initial to final point, but they are longer than path 3, right? So distance is the length of the actual path taken from an initial position to a final position, whereas displacement is the shortest path between the initial and final position, right? Also, there are some other differences, like distance is a scalar, displacement is a vector. Distance is always positive, displacement can be both positive and negative. So in this case, distances and displacement, scalar, it is a vector, it is always positive. Displacement can be in negative direction, and distance is always greater than or equal to displacement. Now then, summarizing, we also had a concept of rate of change d by dt, where dt is a small time interval. So d by dt of distance or rate of change of distance was known as speed. But if you had rate of change of displacement, it gave you velocity. Speed is a scalar and velocity is a vector. And another thing that I have missed is distance is path dependent and displacement is path independent. Now what does that mean? If you cover this path 1 from the initial to final position, or if you cover this path, the distance you cover will depend on the path that you have covered, right? If you take this route, the distance is higher, so it depends on the length of the path you have covered, whereas displacement stays constant irrespective of whichever path you may take. So coming back to speed and velocity, then there is the concept of uniform and non-uniform speed. Uniform speed is whenever a body covers equal distances in equal time intervals. Similarly, we have got uniform velocity, that is when a body covers equal displacement, or when a body displaces an equal length with equal amount of time. So that is known as uniform velocity. And non-uniform velocity or non-uniform speed can refer to a body covering uneven or unequal distances in equal amounts of time, or equal distances in unequal amounts of time. Basically, the amount or the length of the path covered per unit time varies. Okay, and then let us check what is acceleration. So just as we had mentioned that rate of change of distance is equals to speed, and rate of change of displacement equals to velocity, right? So acceleration is the rate of change of velocity. Whenever you have a body that is increasing its velocity at a certain rate, if initial velocity and final velocity of a body are different, in that case we can say that a body is accelerating. ठीक है? So if v initial is 5 meters per second and V final is 8 meters per second, and this much change in velocity has taken, say, 5 seconds. So acceleration will be V final minus V initial by change in time, that is equals to 8 minus 5 by 5 meters per second square, that is equals to 3 by 5 meter per second square, or 0.6 meters per second square, right? That is acceleration. Now acceleration can be uniform or non-uniform, right? Uniform is velocity changes by equal amounts in equal intervals of time. In case of non-uniform or variable acceleration, right, the change of velocity or the amount by which the velocity changes per unit time varies, right? So now that we have discussed so far, there is something that you call as instantaneous you can have instantaneous velocity, you can have instantaneous acceleration. Now what is this instantaneous? Instantaneous means at any given instant. So the formulae for instantaneous velocity or acceleration are very similar. It's just if you have instantaneous velocity, you need to specify the change in displacement by change in time, whereas the change in time is tending to zero, or where the time interval is very short. Okay, so whenever you are driving your vehicle and you see the speedometer mentioning 60 kmph, this is your instantaneous velocity. Now average velocity, we have discussed total distance by total time, and this is the distance covered in a very short time interval. Same goes for instantaneous acceleration, right, where it is the rate of change of velocity with respect to time, right, where dt is tending to 0. Dt is very small. Okay, now another thing that you people need to know is that mathematically speaking, okay, if you have displacement, right, you differentiate it to get velocity, and further differentiate velocity to obtain acceleration. But if acceleration is given, you have to go the reverse way. How? You have to integrate to obtain the velocity, and again you have to integrate the velocity to obtain displacement, depending upon whatever value is provided to you. Let us check this question. So half of a distance is covered at a velocity of 3 meters per second and rest of it is covered at 5 meters per second. Now assume that total distance is x, right? What has been mentioned? Half of the distance, or x by 2, is covered at a velocity of 3 meters per second, and the rest of it, okay, if half of x has already been covered at a velocity of 3 meters per second, so what is the rest half of it? Rest half is again x by 2, and a case will be v2, or the velocity at which it is covered is 5 meters per second. So all of you know that for finding average velocity, we have average velocity equals to total distance covered by total time taken, right? Or in any case, velocity is distance by time, or we can say v1 equals to d1 by t1. बट ए केस रे आमको को वैल्यू दिया जाइए, डिस्टेंस दिया जाइए एंड वेलोसिटी दिया जाइए, एंड t1 is not provided. So first let us find t1. एटी मुझे लिख पारि t1 equals to d1 by v1. Using this time equals to distance by velocity formula, t1 equals to x by 2 by 3 seconds, and t2 is x by 2 by 5 seconds. So t1 equals to x by 6 seconds, t2 equals to x by 10 seconds. Now for total distance, what we have is d1 plus d2, and then time हम बाहर कर सकते. So total time is x by 6 plus x by 10, and in this case we know both d1 and d2 are equal to x by 2, right? So आम लिखा x by 2 plus x by 2 by 10x plus 6x by 60, or x into 60 by 16x. x cancel, 60 by 16 meters per second, 3.75 meters per second. In this case, here I have considered 60 as the denominator and acted on the numerators accordingly, but you can also take 30, since 30 is the LCM of 6 and 10, as per your convenience. So let me know in the comment section if your answer is also 3.75. Now here we have another question, again on average velocity. Now this one is slightly different, ଟିକେ ଅଲଗା ଅଛି. Let us try. A particle moves along a straight line for 20 seconds with a velocity of 3 meters per second. Then moves at 4 meters per second for another 20 seconds and finally moves at 5 meters per second for another 15 seconds. So again, let us break down the question. You have been given 3 instances. Once a body is moving for 20 seconds and at a velocity of 3 meters per second. Next is the same body is moving for another 20 seconds at a velocity of 4 meters per second. And in the third case, it is moving for 15 seconds at a velocity of 5 meters per second. So let us again recall, what do you need for average velocity? That is total distance by total time, right? And now there are 3 distances, right? 3 paths. So let us say d1, d2 and d3. So d1 is a value that you can clearly calculate. Since velocity equals to distance by time, you can multiply velocity into time to obtain distance. So here velocity into time will be 60 meters, here it will be 80 meters, and here d3 will be 75 meters, right? So total distance we can write it as d1 plus d2 plus d3 by t1 plus t2 plus t3, right? That means, so the values are 60 plus 80 plus 75 by 20 plus 20 plus 15, 55 seconds, right? (215 by 55 meters per second. Now I'm leaving it up to your expertise on how to calculate this 215 by 55. You can divide both by 5 and you get 43 by 11. So you can find the decimal value if you want. That's up to you. So किछि मिनट तले आमने डिस्कस करथिले एक्सेलरेशन, वेलोसिटी, डिस्प्लेसमेंट, डिस्टेंस एंड मुझे मेंशन करथिले कि मैथमेटिकली हाउ यू हैव टू अप्रोच. ठीक अछि. So this question is a very good example of that. So displacement is given as x equals to a cos t. Now if you have got any answers that you have already solved for this question, try pausing the video and solving the answer and then comment your answer. तापरे match करिवा. Okay, so I hope you have done it. Let us try. So velocity is rate of change of displacement, that is d by dt of a cos t, that is equals to, now here a is a constant, so a d by dt of cos t, right? So what is d by dt of cos t? That is minus sin t. So it is a or minus a sine t. So now you have the velocity. Again, if you need acceleration, what do you need to do? Acceleration is the rate of change of what? Velocity. So you have to again differentiate velocity with respect to time, and velocity is minus a sine t. So minus a is a constant, take it out, d by dt of sine t, that is equals to minus a is as it is, and d by dt of sine t is cos t, or minus a cos t. So those of you who have found this to be the answer are correct, and those of you who have found a different answer, you are correct but in a wrong way. So you can try being correct in the right way. Okay, now there is another similar question. This is question number 4. Sorry. For a particle moving in a two-dimensional plane, the position coordinates are given as follows. Right? Now find the speed at t equals to 2 seconds. So in this case, before finding the speed at t equals to 2 seconds, can we just find the speed, or can we just find the velocity? Let's try finding the velocity. Right? X and y coordinates are given, they are along a straight line. So let us try. So this will have two components, right? Now there is Vx equal to d by dt of x, and then there is Vy, that's d by dt of y, that is d by dt of 4 sine 5t, that is 4 constant, so 4 rahla bahar hai. D by dt of sine 5t is cos 5t, and then you again have d by dt of 5t, so you get 20 cos 5t. Similarly, d by dt of y is d by dt of 4 cos 5t, or 4 is a constant, 4 को निजवा बाहर है 4, तापर cos 5t रो डेरिवेटिव होची minus sin 5t and d by dt of 5t, that gives us minus 20 sin 5t. Now you have found Vx and Vy. Now remember, when we have a vector along x and we have a vector along y, the resultant vector is, or the resultant velocity in this case, it is the velocity vector, right? So it is Vx squared plus Vy squared plus 2Vx Vy cos 90. So cos 90 is 0. So this complete third term becomes 0. You have got Vx square plus Vy square. Now Vx squared is 20 cos 5t squared plus minus 20 sin 5t squared. That means square root of, What is the square of 20? That is 400. And again minus 20 also has a square, that is 400. Take cos square 5t plus sine squared 5t, that is equals to root over of 400 into 1. Remember, cos square theta plus sine square theta equals to 1, right? So root over of 400 or 20 meters per second. Now that you have found the velocity, and you see that this velocity is a constant. This velocity is not a function of t. There is no term of t here in this final velocity that you have found out. Okay, so we saw a few problems on how to deal with rate of changes, velocity, displacement and all that stuff. And displacement can be mathematically differentiated to obtain velocity, and velocity can be differentiated to obtain acceleration. And तुम्हें मैंने ये जान लो कि if you want to obtain velocity from acceleration you have to integrate, and if you have to obtain displacement from velocity you have to integrate. So displacement to velocity is differentiation. Velocity is given, you have to find acceleration, that's differentiation. Acceleration is given, you have to find displacement, then that means you will have to integrate acceleration with dt to find velocity, and again integrate that to find the displacement. Now there are certain examples which will demonstrate just that. It I would set up a question. Position of a particle with respect to time is given by x equals to at plus bt squared minus ct cubed, where a, b and c are constants. So a, b and c a तीनटा जाक constant. When the acceleration of the particle is 0, find its velocity. So here you are given the expression for the displacement, that is at plus bt squared minus ct cubed, and you are given a condition that acceleration is 0. जो time रे acceleration 0, say time रे you have to find the velocity. What is the velocity, right? So I can find the expression of velocity as dx by dt, that is at plus 2bt minus 3t squared c. Further, I can find acceleration, or I can find the expression for acceleration by differentiating velocity with respect to time, that is a plus 2b. Sorry, give me a second. This is a, this is dA by dt. A is a constant, so it becomes 0. 2b dt by dt minus 3c dt squared by dt, right? That gives us 0 plus 2b minus 3c into 2t, that is 2b minus 60. So now we are at a point where we have found the expression for acceleration, and the condition that has been given is that acceleration is 0. So we can say this is 0. 2b minus 60c equals to 0, or 2b equals to 60c. Now t is the unknown variable here, so let us find t in terms of the known constants. 2b by c, that is t, right? Now that you have found the value of t, velocity expression already तुम मन पारा अछि. What? Velocity is a plus 2b t minus 3c t squared, right? That is a plus 2b into 2b by 6c minus 3c 2b squared by 6c squared, that is a plus 4b squared by 6c, 2 2s are 4, 2 3s are 6, minus 4b squared c by 36 c into c, c squared, c into c, one of the c is cancelled, 4 9s are 36, 4 1s are 4, so you have velocity equals to a plus 2b squared by 3c minus b squared by, this was, the 3 was missed above, by 9 c and the 3 जिसको add missed out, so that is equals to a plus 2b squared minus b squared by 3c. Now how 3c? This is 3 1s are 3 and 3 3s are 9, or v equals to a plus b squared by 3c. So a number of you people have confidence, but I believe you need more of it. You people can solve the questions as easily if you are just confident. Next question to try करिए. Now this is your favorite question. A question time class रे भी करिए a number of times. So here what is given? Velocity is given. So v equals to beta x to the power of 1 by 2, right? And how will displacement depend upon t? So we know dx by dt is velocity equals to b x to the power of 1 by 2 or beta x to the power of 1 by 2. Dx by x to the power of 1 by 2 equals to beta dt. We can integrate both sides, right? Now once we integrate both sides, what do we find? That gives us x to the power minus 1 by 2 dx and beta into dt rho integration is t, right? And x to the power minus 1 by 2 rho integration, x to the power minus 1 by 2 plus 1 by minus 1 by 2 plus 1. There's a constant here. That is equals to beta t plus constant. Now we can again write it as x to the power 1 by 2 by 1 by 2 equals to beta t plus c, right? Or 2x to the power of 1 by 2 equals to beta t plus c. Now we need the dependency of displacement on time, right? From this expression we can see beta t plus c by 2 is equals to displacement to the power of 1 by 2. So displacement itself can be written as displacement to the 1 power of 1 by 2 squared. It is also equivalent to beta t plus c by 2 squared. So let us just count the numerator part. X is proportional to beta squared t squared plus c squared plus 2 beta t c. Now x will be affected by the maximum power of t here. Now assume there is a lower power of t also, but if I say x equals to t squared plus t and say t is equals to 5, so that means x is equals to 25 plus 5. But if t is equals to 20, then this will become x is 400 plus 20. So this value will not affect x much. The lower power of the variable does not affect it much. The dominating term is t squared. So displacement is proportional to t to the power of 2. You can also get question like this same value will be given some expression v equals to any constant x to the power of something 1 by 2 or whatever will be given, and it will ask you like how does displacement depend upon t, or it will mention displacement is directly proportional to t to the power n, so n equals to dash. It will give you some points a, b, c or d, and it will give you very similar looking answers. It will give you -2, it will give you -1, it will give you 1, it will give you 2. It will try to confuse you, but once you calculate you will know the right answer. So in the exam also I believe you people will calculate, and as per the calculation you will be doing all the numericals, whatever numericals are provided. Any numerical is given such that it's a little confusing. So whatever questions you get in your exams, calculate, don't bluff your way, right? And just one part of the news is the last question that you solved is a question from JEE mains, right? So confidence boost, best of luck, adios.